Welcome back to Tech Stack for all you tech enthusiasts. This is part 3 of our React series. In this part, we will cover useRef. Using useRef lets us access DOM elements directly. Uncontrolled components. Using uncontrolled components lets them manage their own state. Passing a function as a prop. We can pass a function as a prop to share behavior. Derived state. Derived state comes from existing props or state. Context API. Using Context API shares data across components without props. useId. Using useId generates unique IDs for accessibility. Custom hooks. Custom hooks let us reuse logic across components. Now we understand what useRef is in React. useRef is a React hook. It lets us create a reference to a DOM element. We can access and control that element directly. It also stores a value that does not cause re-render when it changes. We commonly use it for input focus, timers, or storing previous values. Now let's create a new component, useRef demo. We will use it to understand how useRef works. Now we start by creating the component function. Now, we add the return statement. This is where we will write our JSX for the useRef demo component. Finally, we export the component. Export default useRef demo. This makes the useRef demo component available to use in other files. Now inside the empty fragment, show text useRef demo. Now import the useRef demo component. This allows us to use the useRef demo component inside our app. Now add the component in JSX. This renders the useRef demo component on the screen. Now comment the Bootstrap demo component. Now open the terminal. Run the command npm run dev. This starts the development server. Now open localhost 5173 in the browser. This loads our React application. You can see the text useRef demo displayed on the screen. Now open the useRef demo component. We will start adding useRef examples here. Now create a reference using useRef. This lets us access the input element directly. Now create an input element. Set its type to text. Now attach the useRef to the input element. This lets us access and control the input directly in the component. Now let's test it in the browser. You can see the input box displayed on the screen. Now create an arrow function named focusInput. This function will be used to focus the input box using useRef. Inside the focusInput function, right? Input ref.current.focus. This will move the cursor to the input box when the function is called. Now create a button element. We will use it to trigger the focusInput function. Set the button text to focusInput. This tells the user that clicking the button will focus the input box. Now add an onClick event to the button. This will call the focusInput function when the button is clicked, focusing the input box. Now let's test it in the browser. As you can see on button click, the input box gets focused automatically. This demonstrates how useRef can control DOM elements directly. useRef is very useful for accessing DOM elements directly and storing values that don't trigger re-renders. Now we understand what an uncontrolled component is in React. An uncontrolled component keeps its state inside the DOM. We do not manage its value with React State. Instead, we use useRef to access its current value directly. This approach is commonly used with form inputs. Now let's check the difference between a controlled component and an uncontrolled component. Controlled component. The value is stored in useState. React controls everything. Every change triggers a re-render. Uncontrolled component. The value is stored in the DOM. You access it using useRef. React doesn't track every keystroke. Now let's create a new component, Uncontrolled Demo. This component will demonstrate an uncontrolled component using useRef. Now, start creating the component function. This is the beginning of our Uncontrolled Demo component. Now, add the return statement. This is where we will write the JSX for the Uncontrolled Demo component. Finally, export the component. Export default Uncontrolled Demo. This makes Uncontrolled Demo available to use in other files. Now inside the fragment, display text Uncontrolled Demo. Now import the Uncontrolled Demo component. This allows us to use the Uncontrolled Demo component inside our app. Now add the component in JSX. This renders the Uncontrolled Demo component on the screen. Now comment out the useRef demo component. Now let's test it in the browser. You can see the text Uncontrolled Demo displayed on the screen. Now create a reference using useRef. This will let us access the input element directly in the Uncontrolled Demo component. Now create a function to handle form submission. We will use this to access the input value using the ref. Now I'll make sure to pass the event object E in handle submit. Inside the handle submit function, add prevent default. This prevents the form from reloading the page on submit. Add an alert to show the value of the ref name ref. This will display the current value of the input when the form is submitted. Now to form tag. We will use this form to handle submission with handle submit. Now create an input tag inside the form. Now attach the ref to the input. This lets us access the input value directly using useRef. Now add a button inside the form. We will use it to submit the form and trigger the handle submit function. Set the button's type to submit. This makes the button submit the form when clicked. Now add the onSubmit event to the form. This will call the handle submit function when the form is submitted. Now let's test it in the browser. You should see an alert showing the value you entered. In the text box, enter the value, Welcome to React 19, and click the Submit button. You can see the alert showing the text, Welcome to React 19. This confirms the uncontrolled component is working correctly. An uncontrolled component stores its value in the DOM and is accessed using useRef. Passing a function as a prop in React allows a parent component to share its logic with a child component. This enables the child to trigger actions or update data in the parent, keeping state management centralized and organized. Now let's create a new component showCourses. This component will help us understand how to pass a function as a prop. Now start creating the component function. Now add the return statement. This is where we will write the JSX for the showCourses component. Finally, export the component. Export default showCourses. This makes the showCourses component available to use in other files. Now inside the fragment, display text showCourses. Now open app.jsx. Import the showCourses component. This allows us to use the showCourses component inside our app. Now add the showCourses component using a self-closing tag. This renders the showCourses component inside our app. Now comment out the uncontrolled demo component. Now let's test it in the browser. You can see the text showCourses displayed on the screen. Now we will create an arrow function in the parent component. We will pass this function as a prop to showCourses. Now create the arrow function showCourse. We will add logic inside this function that the child component can trigger. Inside the showCourse function, add an alert with the text React 19. This will show a pop-up saying React 19 when the function is triggered. Now pass the function as a prop to show courses. This allows the child component to call the show course function from the parent. Now open showcourses.jsx. Inside the component, use the prop show course to access the function pass from the parent. Now create a button inside the show courses component. We will use this button to trigger the show course function from the parent. Now add the onClick event to the button. This will call the show course function from the parent when the button is clicked. Set the button text to show course. This tells the user that clicking the button will trigger the show course function. Now let's test it in the browser. It's not working. Let's inspect the code. Now we can see the error. Class constructor alert cannot be invoked without new. The mistake is that we wrote alert with a capital A. In JavaScript, the correct function is alert with a lowercase a. Change alert to lowercase. It will work correctly. You can see that on button click, it now shows an alert with React 19. Now modify the function to accept a parameter course. Inside the function, show an alert displaying the course parameter. Now, pass a prop named course to the show courses component. Now open showcourses.jsx. Receive the course prop along with the function in the component. Now update the buttons on click to use an arrow function. This ensures that when the button is clicked, the show course function is called with the course prop as its argument. Now open app.jsx. Pass the course prop to show courses with the value React 19. This sends the course name from the parent to the child component. Now let's test it in the browser. You can see that on button click, it shows an alert with React 19. Now add one more instance of a show courses component. This will create a second button that shows an alert with Angular 21 when clicked. Now let's test it in the browser. You should see two buttons, one for React 19 and one for Angular 21. You can see that on the first button click, it shows an alert with React 19. On the second button click, it shows an alert with Angular 21. That's how you can pass a function as a prop in React. A function passed as a prop allows a child component to trigger actions in the parent. Hope you understand. Now let's discuss derived state in React. Derived state in React is a value calculated from existing state or props instead of being stored separately. It helps keep data consistent and avoids unnecessary state updates or bugs. Now we will see two examples of derived state. The first example will show derived state calculated from useState. The second example will show derived state calculated from props. This will help you clearly understand how derived state works in different scenarios. Now let's create a new component called Derived State Demo. This component will help us understand derived state with a practical example using state. Now, start creating the component function. Now, add the return statement. This is where we will write the JSX for the derived state demo component. Finally, export the component. Export default derived state demo. This makes the derived state demo component available to use in other files. Now inside the fragment, display text derived state demo. Now open app.jsx. Import the derived state demo component. This allows us to use the derived state demo component inside our app. Now add the component using a self-closing tag. This renders the derived state demo component inside our app. Now comment out the show courses component. Now run the project in the terminal using command npm run dev. Now let's test it in the browser. You can see the text derived state demo displayed on the screen. Now open the derived state demo component. We will implement state in it to demonstrate derived state using useState. Now create a state variable called numbers with a function setNumbers to update it. Now initialize the state using useState. Now initialize the state as an array containing 1, 2, and 3. This sets up the initial numbers for our derived state demo component. Now create a constant total to calculate the sum of numbers. Now use numbers that reduce to calculate the total. This adds up all the numbers in the array to get the derived total. Now create h2 tag to display the numbers array. Use join to display the numbers as a comma-separated list. This will show the numbers neatly on the screen. Now add one more h2 to display the total. This will show the derived total of the numbers array on the screen. Now let's test it in the browser. You can see the numbers array and the total displayed on the screen. So total is a derived state, a value calculated from existing state instead of being stored separately. It updates automatically whenever the underlying state, numbers, changes, keeping your UI consistent. Now create an arrow function called addNumbers. We will use it to add a new number to the numbers array. Now use the setNumbers function to update the state inside addNumbers. Now use the spread operator and add 4 to the numbers array. This keeps the existing numbers and adds 4 at the end of the array. Now create a button inside the component. Set the button text to add 4. Set the buttons on click event to call the addNumbers function. This will update the numbers array and recalculate the total when clicked. Now let's test it in the browser. You can see that on button click, the number 4 is added to the array and the total updates automatically. This demonstrates derived state in action. Now we will check the second example of derived state using props. This will show how a child component can calculate values based on the data it receives from its parent. Now let's create a new component called discount price. This component will demonstrate derived state using props. Now, start creating the component function. This is where we will receive the props needed to calculate the derived value. Now, add the return statement with a fragment. Finally, export the component. Export default discount price. This makes the discount price component available to use in other files. Now inside the fragment, display text discount price. Now open app.jsx. Import the discount price component. This allows us to use discount price inside our app. Now add the discount price component using a self-closing tag. This will render the discount price component inside our app. Now comment out the derived state demo component. You can see the text discount price displayed on the screen. Now open the discount price component. Receive props price and discount in the function. This allows the component to access the price and discount values from the parent. Now open app.jsx. We will pass the price and discount props to the discount price component from the parent. Now pass the price prop with a value of 100 to the discount price component. Now pass the discount prop with a value of 3 to the discount price component. Now open discountprice.jsx. We will calculate the final price using the price and discount props. Now remove the text discount price from the fragment. Now add h2 tag to display the original price. This will show the value of the price prop on the screen. Now add one more h2 tag to display the discount. This will show the value of the discount prop as a percentage on the screen. Now format the price with a $sign and the discount with a percentage sign. Now let's test it in the browser. You can see the original price displayed with a $sign and the discount with percentage sign. This confirms that the props are being passed and displayed correctly. Now create a constant called final price to calculate the price after discount. This derives the final price from the price and discount props instead of storing it in state. Now add header h2 tag to display the final price. This will show the price after applying the discount on the screen. Now let's test it in the browser. You can see that the original price is $100, the discount is 3%, and the final price is $97. This confirms that the derived state from props is working correctly. Derived state from props is a value calculated in a child component using the data received from the parent. It updates automatically whenever the parent props change, keeping the UI consistent. Now let's discuss the Context API in React. Context API in React is a way to share data across components without passing props manually at every level. Normally, data flows parent-child via props. If a deeply nested component needs something, you end up passing props through components that don't even use them. That's called prop drilling. It's annoying. Everyone pretends they like it. Nobody does. In the Context API, we have three important concepts. First, create context. It is used to create a new context. Second, provider. It is used to wrap components and provide the shared data to them. Third, use context. It is used inside a component to access the data from the context. These three concepts work together to share data globally without prop drilling. Now, let's understand this with a practical example. In this example, we have a component tree. At the top, we have the app component. Below that, we have parent, then child, then grandchild, and finally great-grandchild. Data normally flows from app down to each level using props. If great-grandchild needs some data from app, we must pass it through parent, child, and grandchild. Even if those components do not use the data, they still receive and forward it. This is called prop drilling. With Context API, we create a context in app. We wrap the components with a provider. Now great-grandchild can access the data directly from context. We do not need to pass props through every level. This makes the code cleaner and easier to manage. Now let's create a new component called parent. Now quickly create the parent component with its function, return JSX, and export it. Now let's create a new component called child.jsx. Create the basic structure with a function, return JSX, and export it. Now let's create another component called grandchild.jsx. Create its basic function, return JSX, and export it just like the other components. Now let's create one more component called great-grandchild.jsx. Create its basic function, return JSX, and export it like the other components. This component will be deeply nested and will use useContext to access the shared data directly from the app. Now open app.jsx. Comment out the old components so they don't render. This will help us focus only on the Context API example. Now import the parent component in app.jsx. This allows us to render the parent component inside our app. Now add the parent component using a self-closing tag. This will render the parent component and all its nested child components in the app. Now open parent.jsx. Import the child component so we can use it inside parent. Now render the child component inside the parent component. Now open the child component. Import the grandchild component so we can use it inside child. Now render the grandchild component inside the child component. This nests grandchild under child in the component tree. Now open the grandchild component. Import the great-grandchild component so we can use it inside grandchild. Now render the great-grandchild component inside the grandchild component. This nests great-grandchild under grandchild in the component tree. Now open the terminal and run the command npm run dev. This will start the development server and open the app in the browser. Now let's test it in the browser. You can see all the components, parent, child, grandchild, and great-grandchild, are rendered in order. But only great-grandchild is showing because we removed the text from the other components. Now we will add text inside the other components as well. This way, you will clearly see parent, child, grandchild, and great-grandchild displayed in proper order on the screen. Now in the parent component, add h1 tag to display the text parent. This will make the parent component visible on the screen. Now in the child component, add h1 tag to display the text child. This will make the child component visible on the screen. Now in the grandchild component, add h1 tag to display the text grandchild. This will make the grandchild component visible on the screen. Now let's test it in the browser. You can see all the components are showing parent, child, grandchild, and great-grandchild. This confirms that our component hierarchy is rendering correctly. Now create a new file called usercontext.js. This file will be used to create the context that we will share across our components using the Context API. Now create and export the new context called userContext. Now initialize the context using createContext. This sets up a context object that can be shared across components. Now open app.jsx. Import the user context we just created. This allows us to use the context provider to share data in the component tree. Now wrap your components with the user context provider. Now place the parent component inside the user context provider. This makes the context data available to parent and all its nested child components. Now pass a value to the provider with an object with name property. Now set the name in the provider value as John. This will make John available to all nested components via the context. Now open the great-grandchild component. Create a constant user to access the context data. Now use the useContext hook with userContext to access the context inside great-grandchild. This allows you to get the shared data. Now display the context value inside the component. Now let's test it in the browser. You can see Hello John displayed on the screen. This confirms that the great-grandchild component successfully accessed the context value using useContext. Now we will handle the context value using state. This will allow us to update the context data dynamically and see the changes reflected in all components that consume it. Now open app.jsx. We will modify the provider to use state so the context value can be updated dynamically. Now create a state variable for the context value. This allows us to update the name dynamically and pass it through the provider. Now pass the state variable name instead of the hard-coded value to the provider. This allows any component consuming the context to read and update the name dynamically. Now let's test it in the browser. You can see Hello John on the screen. This confirms that the context is now using state, so the value can be updated dynamically if needed. Now change the state value to Edward and test it in the browser. You can see Hello Edward on the screen. This confirms that updating the state in the context dynamically updates the value in all consuming components. Now let's create an input field to update the context state dynamically. Now handle the input change to update the context state. This updates the name state whenever the user types in the input field, and all components consuming the context will reflect the change. Now let's test it in the browser. You can see that when you type in the input field, the text updates immediately. This confirms that the context state is dynamic, and all consuming components reflect the changes in real time. Let's conclude what we learned about the Context API. In this example, we have a component tree. App at the top, then parent, child, grandchild, and finally great-grandchild. Normally, data flows from app down to each level using props. If great-grandchild needs data from app, we would have to pass it through parent, child, and grandchild, even if those components don't use the data. This is called prop drilling. With the Context API, we create a context in app and wrap the components with a provider. Now great-grandchild can access the data directly from context without passing props through every level. This makes the code cleaner, simpler, and easier to manage. Now we discuss the useId hook in React. useId is a React hook that generates a unique, stable ID for a component. It's mainly used for accessibility, linking labels to inputs, avoiding duplicate IDs, working safely with server-side rendering (SSR). It was introduced in React 18. Now we create a new component called useId demo. Now we will create a function called useId demo. This function defines our component. Now we will return some JSX from the component. We use empty tags as a placeholder for now. Finally, we will export the useId demo component. This makes it available for use in other files. Inside the fragments, we will show the text useId demo. Now we will open app.jsx. We will comment out the old code inside it. Now we will import the useId demo component. Now we will use useId demo as a self-closing tag in our JSX. Now we will run the command npm run dev to start the development server. Now we will open the browser to test our component. We will check that useId demo displays correctly. You can see the text useId demo on the screen. Now we will create an input field inside the component. Now we will set the ID of the input field to email. Now we will copy and paste the same input field. We will use the same ID email for it. Now we will test the app in the browser. You can see two text boxes on the screen. Now we will inspect the elements in the browser. You can see both text boxes have the same ID. In React, duplicate IDs can cause problems too. The browser does not know which one to use. Screen readers get confused. It can break your app. Now we will create a constant called ID. Now we will use the useId hook to generate a unique value. This will prevent duplicate ID problems in React. Now we will remove the first input field. We will add a label for the remaining input field. We will set the label's HTML for attribute to ID. This links the label to the input field in React. In the label, we will set the text to email. In the input field, we will set ID equals to ID. This connects the input to the label using the unique ID. Now we will test the app in the browser. You can see the email label with its text box. Now we will inspect the elements in the browser. You can see the label and input with a unique ID. The label has 4 and the input has ID underscore, R underscore, 0 underscore. This ensures they are correctly linked in React. Now we will create a new constant ID 2 using useId. This gives us another unique ID for a second input. Now we will create a new input element for the second field. We will use the unique ID stored in ID2. Now we will test the app in the browser. You can see two text boxes on the screen. Now we will inspect the elements in the browser. You can see both input fields have their own unique IDs. There are no duplicate ID warnings. We use useId when we connect a label and input. We create accessible form fields. We need a consistent unique ID for each component. Do not use useId for keys and lists. For that, use actual unique data instead. A custom hook is a JavaScript function in React. It lets us reuse stateful logic across components. We name it starting with use, like useForm or useFetch. It can call other hooks inside it. Custom hooks keep our code clean and organized. Now we will create a new component called users. Now we will create a function called users. This function defines our users component. Now we will return some JSX from the users component. We use empty fragments as a placeholder for now. Finally, we will export the users component. This makes it available for use in other files. Inside the fragments, we will show the text users. Now we will open app.jsx. We will import the users component into this file. Now we will use the users component as a self-closing tag in our JSX. Now we will test the app in the browser. You can see the text users displayed on the screen. Now we will create a new folder called hooks. This folder will store our custom React hooks. Now we will create a new file called usefetch.js inside the hooks folder. This file will hold our custom fetch hook. Now we will create a function called useFetch. This function will be our custom hook for fetching data. Now we will pass a URL parameter to the useFetch function. This lets the hook know which API endpoint to fetch data from. Now we will create state inside the hook. This will store the data we fetch from the API. Now we will create a loading state. This will track if the data is still loading. Now we will set the initial state of data to an empty array. Now we will set the initial state of loading to false. Now we will return an object from the hook containing data loading. This allows components to access the fetch data and loading state. Now we will define a use effect inside the useFetch hook. This will run the fetch logic when the component mounts or the URL changes. Now we will use an arrow function inside useEffect. This function will contain our data fetching logic. We will add URL as the dependency array in useEffect. This ensures the effect runs whenever the URL changes. Now we will use fetch URL inside the effect to get data from the API. Use then to convert the response from the fetch call into a JavaScript object. Residential is the response from the server, and residential.json reads it as JSON. This allows us to work with the data inside our app. Now we will chain another then to handle the parse JSON data. Now we will use result inside the then. This function receives the parse data and lets us process or store it. Inside the function, we will call setDataResult. This updates our state with the fetch data. After setting the data, we will call setLoading false. This marks that the data has finished loading. Now we will set the initial value of loading to true. This shows that the data is loading when the component first renders. Now we will set the initial value of data to null. This means there is no data before the fetch completes. Now we will import the useFetch hook into the users component. We're trying to import useFetch, but it is not showing. We probably forgot to export it. Now we will open usefetch.js to fix that. Now we will add export default useFetch at the end of usefetch.js. This makes the hook available for import in other files. Now we will open the users component. We will import the useFetch hook there to use it. Now we will call useFetch inside the user's component. We will destructure it as const to access the fetch data and loading state. Now we will remove the existing JSX code from the user's component. We will prepare it to display the fetch data instead. Now we will add a condition to check if loading is true. If it is, we will return text loading in paragraph to show a loading message. Now we will return the data as formatted JSON. We will use the pre-tag in JSON.stringify to display it nicely in the browser. Now we will test the user's component in the browser. You can see the loading message is showing. We have not passed any URL to the useFetch hook yet. In the browser, we will search for JSON placeholder. We will open the first link. We will use the API URL from that site in our app. Now we will scroll to the bottom of the page. We will find the user's endpoint, open it, and copy its URL. Now we will paste the copied URL into the useFetch. This will allow the hook to fetch the user's data from the API. Now we will test the app in the browser. The app is showing nothing. We may have made a mistake in the code. Now let's check it. Oops, we used data.null with a dot by mistake. We should use a comma. Perfect, you can see the user's data displayed now. Now we will use the Todos API from JSON placeholder. This will let us fetch and display a list of Todos in our app. Now we will paste the Todos API URL into useFetch and test the app again in the browser. You can see the Todos data displayed as formatted JSON. This demonstrates how custom hooks work in React. We should create a custom hook when logic is repeated across components. We want cleaner, simpler components. We want to separate logic from the UI. If you're passionate about learning new technologies, make sure to subscribe to our YouTube channel, Tech Stack, and keep learning new skills. Thank you. And remember, consistency is the key to success.